Welcome to our video on increasing, decreasing, and the first derivative test, starting to really get to use these derivatives and importance of them and what they can tell us about a function. Okay, so first off, let's talk about the increasing, decreasing test here. So assuming that f is continuous and differentiable, that's always important for any of these derivative tests. If f prime is greater than 0, then it's increasing, which makes sense because it's saying if the slope is positive, it's increasing. Duh. If f prime is negative inside the interval, then it's decreasing. So again, all the slopes are negative. So the first derivative test for local extrema is saying that it's going to tell us that if f is continuous, it's differentiable, then if f changes from negative to positive on C, then it has a local maximum. If f prime changes from positive to negative, then it has a local sorry, I think I said that wrong the first time. F changes from negative to positive, it's a local minimum. And f changes from positive to negative, that's a local maximum. If f does not change at all, then there is no local extrema. So for example here, look at this little tiny picture. Zoom in on it for you up here. So let's find a maximum. So we see here how the derivative is positive, 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 and then it's 0, and then it changes. Well, that's a local maximum. And let's look at this one right here. We're negative, 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 and it changes to positive, positive, positive. That's going to be our local minimum. And here's the instance where it doesn't change. It's increasing, increasing, increasing. It is 0, but then it's increasing, increasing, increasing. That doesn't tell us anything. So there is no actual extrema there. An extrema is the same thing as like relative max, relative min, local max, local min. Those are the same things, relative and local. But we're not looking for absolute here, and that's very important to note as well. We're not looking for what's the highest point. It's just, hey, it's the highest point in this little tiny interval. Okay, so maximum, minimum, there's a high point, there's a low point. The high point isn't necessarily the highest, the low point isn't necessarily the lowest. So we're going to go through a problem here, and that's it, just one problem. So we're going to find the intervals where f is increasing and decreasing, and we're going to identify all points that are relative maximums and minimums, and then we're going to go ahead and justify our answers. Justifying our answers are not paragraphs, they're just real quick, boom, answers. It's really just straight up saying, oh, derivative is positive, so now it's increasing. Derivative is negative, so now it's decreasing. Okay? So first things first, in order to see anything about our extrema here is we have to find the derivative. So let's go ahead and do that. I'm going to do that over here. So I'm going to get f prime of x. This is going to be a little bit of quotient rule here. So it's going to be the first is first times the bottom minus the first, and the second is second. So derivative is going to be 2 all over the bottom squared. This is going to require just a little bit of cleanup before I really can do anything else. I'll make this look nice and neat here. So I'm going to get 4x squared minus 2x minus 2x squared all over this 2x minus 1 squared. And this is going to give us 2x squared minus 2x all over 2x minus 1 squared. So we need to find all of our critical points. There's 2 of them. There's singular and stationary. So stationary, again, is when the function equals 0. And that's what people always get. Sometimes people forget about the singular points, and that's when you got to find out when it's undefined. In this case, we are going to have undefined because this is a fraction, and I know that the bottom can never equal 0. So we're going to go ahead and find all of those super-duper important points here. So first, I'm going to do f of x is, or sorry, f prime is equal to 0. So when I set it equal to 0, I'm going to get 2x squared minus 2x equals 0 because the bottom is going to cancel out. And I'm going to get a GCF here of 2x. So I'm left with x minus 1 equals 0. So I'm going to have a critical point at, when I set that equal to 0, I'm going to get x equals 0 and then x equals 1. So what I'm going to do here is I'm going to make a bit of a number line. I'll do the number line in green. So I'm going to make a number line and put all my important numbers on here. I have arrows going from right to left because I don't have anything being restricted here. And I'm going to start to plot these points here. And actually, just a second, because I want to make sure I leave enough room between all my critical points. So I got all of my not all my critical points, but all of my stationary points, I need my singular point. So I need to set the bottom now equal to 0. This is when it's undefined. Okay, so I'm going to go 2x minus 1 all squared equals 0. You square both sides, so you're going to get 2x minus 1 equals 0. You're going to get x equal 1/2. So I'm going to label these three things on my number line. So I'm going to go with 0. I'm going to go with 1/2. I'm going to go with 1. Now, this is my number line on f prime. Some people ask me, hey, are we plugging these numbers back into the original or the derivative to find out if it's increasing or decreasing? Well, in order to know if something's increasing or decreasing, we need to plug it back into the derivative. So the easiest thing to do here is we got to find out if it's positive or negative, is to plug it into our final ratio. Okay, so we can plug it back into there. We can figure out, is it positive or negative? Now, this can simplify a little bit more, which is probably going to make our life a little bit easier with plugging it in. So what color? I'll go gray here. So just to simplify this just a little bit more, because if you saw here, I did factor it more. If I go 2x, x minus 1, all over 2x minus 1 squared. So I'm going to plug in my values in here because it's just a little bit easier to figure out if it's positive or negative. Take note as well is that no matter what you plug into the denominator, that's always going to be positive. Okay, so let's plug in a number in this interval which is less than 0. So pick a number that's less than 0, that's easy to plug in, -1, and we're going to test this out. So I'm going to get a negative times a negative all over a positive. So negative times negative. If you don't know that, you do it on the side here. So you're going to get negative, negative all over positive. That's going to give me positive over positive, which is going to be a positive. So this is a big old positive. So I just put my work on the bottom, my actual value on top. All right, pick a number between 0 and 1/2. Ugh, 1/4. We're going to go positive. 1/4 minus, that's going to be a negative all over a positive. That's going to give me a negative value. Plug a number between 1/2 and 1. Ooh, these are just not great. 3/2. Plug in a 3/2. I'm going to get positive. 3/2. Plug it in there. I'm going to get a negative all over, always positive. So I'm going negative, negative on that one. Plug a number that's bigger than 1. Ooh, thank you. A number I can do. Pick like a 2. So plug in a 2. Positive, positive all over, positive, which is going to give me a positive number. Okay. So my work's on the bottom here, and then on top is what's actually going on with that function and those intervals. One thing that I do as well is I'll kind of draw what's going on with this. So I'm going to draw an up arrow because I'm increasing. Since it's negative, drawing a decreasing arrow, and then I'm drawing a decreasing arrow, and then I'm drawing a increasing arrow. The reason I do this is this helps me personally to figure out if it's going to be a local min, local max, or nothing. So you can kind of see here, like, oh, it's up and down. This is going to be a local max right here at 0. And then look at 1/2. Oh, it's decreasing, decreasing. That nothing. And then decreasing to increasing. Well, that's going to be a local min at 1. So this wants us to find all of the points where it's increasing, decreasing. So that's not that big of a deal. So let's go for it. Well, it is in color. Oh, I haven't touched red yet. So here we go. When is this increasing? So it's increasing, and these are going to be intervals from -infinity to 0. You don't need to put u's between anything like you did back in pre-calculus, and then from 1 to infinity. You need to state why. It's as simple as this. Because f prime is positive. POS, good enough. So f prime is positive. When is it decreasing? It's decreasing from 0 to 1/2, and then from 1/2 to 1, put commas between those so that they're two different intervals, and that's because f prime is negative. Now there is some type of debate in the math world. I have a hard stance on this one that you can use with these closed brackets or open brackets. I always pick open with these because you're technically not decreasing at 0 because it's 0 at 0. So I always just use the open brackets, but AP will take either one. Now this is going to be the relative max. That's what's next. So relative max. So this wants the point. So point, not just the x value. So we need to plug in a 0. So it's going to be the point 0 comma what? Plug in a 0 into here. You're going to get 0 over something. So it's going to be 0. So we have a relative max at 0, 0. Why is that? Because f prime changes from positive to negative. All you're doing is just reading off your chart. And this is all the justification you need. If you notice, justification is because f prime is positive. That's it for the increasing. F prime is negative. That's it. No sentences here. F prime changes from positive to negative. And that's good enough. That's what we need. And then my relative min, might need to cheat on this one to see what this number is going to be. Plug in a 1. So you get 1 over, is it 1 over 1? It is. 1, 1. And that's because f prime changes from negative to positive. And that's how you use the first derivative test to figure out what is going on with this function right here in terms of increasing, decreasing, relative max, relative min.